this is how we're going to approach any type of problem that looks like a z-score problem. Okay. So the first thing that we do when we read a problem, let's just grab one from the textbook. Okay, page 153 in your textbook. Transforming SAT scores into z-scores. So in any general question, you're going to be given pieces of information about the distribution. Normally the question will say, if x is distributed normally, well then I go, okay, normal, I need to draw a curve. So step one is draw the curve. Oh, that's a good looking curve. If it's a normal distribution, I have my normal curve. I'm just going to draw it. Because then I need to figure out what it is about this curve that I need to find. So the example in the book says that we need to find the percentage of scores between 500. So what is the area between 500 and 700 of SAT scores? Now, I'm not going to put them on my curve yet because I don't know where they are relative to the curve. But since it's a normal curve, I might as well just go ahead and figure out what the middle point is. All right, what is the middle point of a normal curve? No. 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 Ben? The mean. Okay. So this is where our mean is, right? Our mean is the midpoint of the curve. Those of you who had 0, you were kind of right. Why were you kind of right, those of you that said 0? Or the z-score, right? Because a z-score has in the middle the value of 0. Okay, so I'm okay with that, but it's not what I was looking for. So in our example from the textbook, the mean SAT score is 500. And the standard deviation, our sigma, is 100. Okay. So, for scores of x, the mean is 500. I want to find the area between 500 and 700. I want to find this shaded area. So what do I do first? Well, I've taken stock of all the information that I have. I know it's a normal curve, so I drew the normal curve. I know what my mean is. My mean is 500. I know that my sigma is 100. I know that the question wants me to find that slice of the curve and how much area is in there. So how do I do that? Jake?
Find the z-score of 500 and 700.
Okay, first step, find the z-score of 500 and 700. I already know the z-score of 500. I don't even have to do any math. Why? Because it's the mean. So in my equation of x minus mean, 500 minus 500 is 0. Doesn't matter what the standard deviation is, because 0 divided by any number is 0. And I also know what the area is with a z-score of 0. It's 0.5, right? So look at that. I now have 3 values on this bottom axis of this graph, and they all line up. They're all measuring something slightly different, whether it's our value of x, the score that we're interested in, or a z-score, or an area. Now I have to do the same thing for 700. So what do I do? Well, I need to find the z-score, this number here, that represents a score of 700. So let's see, I need to find z. That's this equation here. Z equals 700 minus our mean, which is 500, divided by sigma, which is 100. Math tells me that 200 divided by 100 is 2. So this z-score here is a 2. I need to do what now? Need to what? I need my chart. Crap, I don't have my chart up. So I'm going to rely on you guys to tell me what a z-score of 2.00 becomes. What is it?
0.977.
Is that correct? I don't trust Joey. Tom?
I have a question.
Yes, sir.
So if it's like not blatantly obvious that 700 is 200 more than 500, you just look at it and you're like, okay, 500 is the mean, 700 is what I'm kind of fine. Without even doing the equation, you could just be like, standard deviation is 100, so that's 200 more. Like, can you just, will it always work to just do it in your head like that? Or?
Will it always work to do it in your head like that? No. All right, these are like the most general numbers we can have.
I mean, even if it was like,
but if you
560 and the standard deviation is 30, you know that 60 is 2.
Yeah. So what Tom is pointing out is that sometimes you can just look at the numbers and go, oh, well, that's twice as much as the mean, and 2 divided by the mean. Hey, I got 2, right? And I know it's 2 standard deviations. Do I really need to go further? Bucket on the floor, right? The whole concept of being better in math is repeating the steps that we know work. And so if you do it my way, you'll know how to do it no matter what the standard deviation is relative to how the other numbers. So yes, you've picked up on that. Good job. Virtual high five. But I want bucket on the floor. I want you all to do it the same way every time. And so when it's not that obvious, I don't want you to just go, it's about 2 sizes of the standard deviation, right? I don't want you to do that. I want you to be precise. So yes, good job for noticing that, but don't do it. Bucket on the floor. Let's do it the same way every time. Okay, so we've got our 2 values of x. We now know the z-scores of those 2 values, and we now know the area under the curve that corresponds to those 2 values. What do we do next to find out where our shaded part is? Because our question was, what's the area, or what percentage of test takers are between 500 and 700? What do we need to do now? Aaron says subtract. What from what? You said it backwards. We're subtracting 0.5000 from the larger number. So, what's our answer? What percentage of test takers receive a score between 5 and 700 on the SAT? 47.72%. Okay? Who wants me to do another one? Just one more. All right, I saw a hand. We're going to do one more. Let's do a question from the homework area. Exercises 11 through 13 on page 169 are based on the following example. Imagine you're the president of a toy company that builds video games. You have determined that the time needed to build these games is normally distributed. All right, I heard that name. I'm going to draw my little curve. I want my curve back. With a mean of 20 and a standard deviation of 5. Now question 11 is going to ask us what percentage of the video games is built, and then it's going to give us a series of times. Okay? I have 6 rows of people. I'm going to assign you each a different one. This row, less than 15 minutes. So write that down, less than 15 minutes. This row, less than 10 minutes. This row, more than 20 minutes. This row, more than 30 minutes. This row, between 26 and 32 minutes. And this row, between 12 and 24 minutes. All right, let's pause for a couple of minutes and I'll let you guys work it out. All right, Aaron, for A, what do we do first?
I use the z equals x minus. I did z equals 15 minus 20 over 5.
15 minus 20 over 5.
Negative 5 over 5. Z equals 1. And then z squared is 0 and 5.
No. What's the z equal? Negative 1. Okay. What's the z-score for negative 1?
0.1587.
Okay. So what percentage of the video games can be built in less than 15 minutes? Yes. You just didn't say negative. You lost your negative. All right. B. In less than 10 minutes. You do it, Joey.
Did 10 minus 20 over 5 came out to negative 2. Negative 2 is 0 or 0.0228, which is 2.28%.
Okay. That sounds good. Now C, the original question was more than 20 minutes. And Ben, why was that an easy one? Yeah, because the mean is 20, and so 20 minus 20 is 0. So it's half, right? Half the games can be built in more than 20 minutes. But then I changed your question and I said in less than 30 minutes. So what do we do? You subtracted, right? Because you said over. I thought you were trying to do a fraction there. Okay. .4772. Why are you shaking your head, George? Yeah. So the mean's 20, and I said 30. You find the area for 30. The table gives you the area from 30 all the way back here. Not sure why you subtracted it. Okay. Next group was more than 30 minutes. So you had about the same question. What did you do different to find your answer?
Find the superior to the right.
So Danny, what is that?
So we subtracted the 0.9772 from 1, and that's how we found
And the answer is?
that. 0.022.
Okay, which is 2%.
Did all by myself.
Yay. All right. D, that was you guys. E, you had to do between 26 and 32. So how do we do that one?
I did 26 minus 20 over 5.
So the first step is 26 minus 20 over 5.
Which is 6 over 5, which is 1.2.
Okay.
And then to find it on the z-score, it's
0.8849. Okay. Now what?
and then you have to do the one for 32.
Okay.
32 minus 20 over 5, which is 12 over 5, which is 2.4. And then the z-score for that was 0.9.
Okay. Now what?
And then subtract 0.8849, which is 0.1069. So it would be 10.9 or 10.69.
Yep. Did you get that? Okay. Last one is between 12 and 24 minutes. Walk us through it. No? All right, let me do it then. So I got my curve. I know I need this area here between 12 and 24. 12 minus the mean, 20, divided by the standard deviation is a negative 8 over 5. I have to get my calculator out because that's what I have to do. Negative 8 divided by 5, negative 1.6. Now 24 is my other value. 24 minus 20 divided by 5 equals 4 out of 5, which equals 0.8. So these are my two z-scores. Somebody who has their z-table out, give me the area for negative 1.6. And for 0.8. So the answer is 73.33% of games can be produced between 12 and 24 minutes. Okay? What was your question?
So I was trying to do it here, but like after I got my answer, I think I put the minus and a half.
Okay.
So like basically like minus half of this like
So let's think about the problems that we've had. The first set of problems were less than a number. So we put our number on here. We find the area for that. And that number that we found is the area less than our number of interest. So what was yours, A's? You had to do less than, right? So less than 15. So they found the z-score for less than 15. And the way our chart is set up, when you look at the little picture at the top, it shows you that that number in the field of the chart represents the little picture, which is from the beginning up to that point. Okay? The next group So you were less than, you were less than. Yours I screwed up, gave you too easy of a one. And then I gave you a harder one, which your number was 30, right? Well, our mean was 20, and I gave you 30. So less than 30 is all of the area up to 30. So it's just the number that you find in the chart. Then we switched and we did more than. So let's say I have a number that's 40. I don't know why it does that, but it does. All right? So I need to find the area more than 40, so I need to find this area on this side. But that's not what the chart does. Right? The chart doesn't give me the area to our right. It gives us the area to the left. So what we do is, knowing that the full curve is full of 1, we find this area here to subtract it, and that the leftover is the shaded area. Does that make sense? Okay. Listen, I always, out of practice, because for me it's bucket on the floor, I always shade the area I want, because that tells me find this chunk, right? You don't have to do that. If that doesn't make sense to you, you can just draw it as it's shown on the table, but you still have to do that step of subtracting it from 1. Okay? So whatever your process is, it can be different, but for me, I always shade what I have. And then one of the things that I usually do when I'm doing this is I always write the area that I've found in the table in that area, even if it's not the area I'm looking for, right? Because I now have a known. I know that the area to the left, right, as we're looking at it, is what the chart gives me. I'm going to put that on my little picture. And that way maybe if I need to, I can figure it out. Okay? What happened with you? You don't know? You just froze up? Because you have the answers. You were getting there. Right. So we have a process with z-scores. Draw the curve. Write down the knowns. Figure out what we have to compute. Find the areas from the tables. Answer our question. That's how we work a z-score. Anybody want to do one more? Yeah? All right. One more. Everybody close your eyes and think of a number. Between 1 and 100.
13.
Thank you. George, what was your number?
68.
Tyro, what was your number? 21? Okay. This side of the room, find the area of the curve greater than 21. This side of the room, find the area of the curve less than 21. All right, let's go. First thing we do, draw a curve. What do we know about our curve? The mean is 13. I've asked you to find either greater than or less than 21. So what do I do first?
Subtract 13 from 21.
No. How the hell would I do that? My question was, what do I do first? Bucket on the floor. What's the first thing we do? You could shade. You had the right answer, you just said it wrong. What are you doing first? You're not subtracting numbers, you're finding the z-score. Okay, so I got to find the z-score for what? For 21. So let's find what this z-score is, which I do by
Subtracting 13 from 21. Divided by 68. Which gives you 0.11.
0.11. It's a z-table, so I need at least two figures. So if my number is 0.1176, and I need two figures after the decimal, what is it really? No, I need two after the decimal. It's 0.12. So z is 0.12. Okay. Now what?
Greater than, you pop it on the chart.
Well, for anybody, what do you do first? You go to the chart. What's the chart tell me? What area is associated with a z-score of 0.12? 5, 4, 7, 8. Over here, right? Okay. What was this side of the room asked to do? So what's the area, what's the percentage of the cases greater than 21? And our answer is? Is that it? You all have calculators. I'm doing this off the top of my head. Okay, so you are saying that 45% is greater than 21. And you guys say, how much is less than 21? 54.78. Everybody get that answer? Did you get that answer? Yeah? Okay. One more wrinkle. Because so far, we've been doing this. All right, and now that we're comfortable with it, let's remember that we can decide what the percentage is. Right? So I want you to do one more question. With these numbers, find me the middle 90%. So I've given you the answer. I've given you the area. And now I need you to just realize I deleted the statistics for it on you. Find the percentage in the middle. No, you shouldn't find 0.9 in your field. That would be wrong. And one more minute and then we're going to do this together. Actually, let's just see. Raise your hand if you have no idea what to do. More than half. All right? So, we have to be comfortable with our curve. I know that I need to find the two scores of x that give me the 90% in the middle. So, how much does that leave that I need to find over here? Why 5%, Jake?
Because the tails are equally distributed as 5% piece, so that you 10 plus the 90 in the middle, 100.
Absolutely. So I know that the total area under the curve is 1. I've used up 0.9 of it, which means I have 0.1 left. But my curve is symmetrical, so I have to split that up into halves. Does everybody see why I have to do that? Right? I have to do that because I can't put all of the 10% in one area unless I said, find me the top 90% of the scores. But I didn't. I said, find me the middle 90% of the scores. If I said, find me the first 90% of the scores, then you could pack it all in that way, right? But I said the middle, which means that I'm going to have some higher and some lower. Okay, so look up in the table. What's the z-score associated with 0.0500? And I want the z-score, so it's going to be like 0.00, right? So you're going to find in the field in here where you have 0.05.
Oh, I see.
So 0.03, 04, 05, 48. No, that's a little too high. 409. Right? So it's somewhere between
Negative 1.604 and or
negative 1.6, and it's somewhere between 4 and 5, right? It looks to be equidistant between 4 and 5. All right, so negative 1.45. Sorry, yeah. 1.6 and then 4, 4 and 5. I'll just split the difference. Okay? We ready? There are tables that are more precise and will give you the exact number. There are also little applets you can use to get the exact number. So now I have my z, and I need to find x. I'm going to use this equation right here. Negative 1.645 times my standard deviation, 68, plus 13. So somebody do that using math. Negative what? No, you did something wrong. We do multiplication first. So do this part first.
Negative 98.86.
Plus,
No, that's the
oh, that's your answer. Yeah, that's right. Okay? So you do the multiplication first, and then you do the addition. So you got a really big negative number, and then you're going to add 13 to it. Okay? Yeah, Aaron? How did I get the negative 1? All right, let's do this one more time. What was my z? Negative 1.645 times 68. In my calculator I go, negative 1. Oops.
No, my question was how did you find out?
How did I find it on the chart? Sure, I looked for 0.05. You're on the wrong page, right? 0.05. 0.046, 043, nope. 0.05, there we are. Let's get it down as close as possible. 0.0505 or 0.0495. So I took the midpoint there.
Okay, got it.
Negative 1.64 and then 45. That's where I got that from. So don't forget that the back, all right, has the negatives. If we're less than the mean, we're on the negative side. If we're greater than the mean, we're on the positive side. All right, we were looking over here because this area here was 0.05. We're on the negative side. Make sense? All right, that's my time. Finish up your homeworks for Friday, which is on chapter 4. If you couldn't do anything today, you need to come see me in my office.